So in these sections, we simply focus on more on the concept of the stress. And I will review and go over again the calculations and the units here. So in concept, to calculate the stress, basically here should be in Roman character sigma. So sigma should be equal to magnitude of the F divided by the magnitude of the cross-sectional area. Like this. For this case, this area we pick is that big. For this one is we pick is bigger. And you might have a question is how do we choose which cross-sectional area we like to use for calculation? This question will be regarding to the design, and then in this class, and from example to examples, I will show you how to pick the right cross-sectional area to extract the important information. So this is the formulas we applied, and just like the example we're showing there. And so we look at this example. So using this example, I want to show you how to calculate the stress. And so here we might be able to calculate is this. And this one is a very typical example from your statics. And for example, this is a 2-bar structures, and here is pinned here. And on this side, this structure is to carry 30 kilonewtons of the loading here. So we want to calculate what will be the stress in each bar. So again, the concept of the thinking is this. Let me work on this way. So if we like to calculate the stress in this portion and in this portion, then using our concept, the stress equal to F divided by cross-sectional area. So by all means, we need to first determine what is the force in this portion, what is the force in this portion. And that force is about the reaction of the structures. And then as far as the cross-sectional area, then we can read by the dimension, we will be able to determine A. So the first step for this question is to determine the force. Let me take the free body diagram around this portion, so just like showing here. So this one, Fc, is the internal reactions which represent the force being transmitted in this portion. So we're going to use Fc to calculate the stress in this portion. And then Fa is the force being transmitted in this portion, then we're going to calculate this one. So let me work on this one, let me get up this screen. So again, to calculate the stress, so stress in this portion, let me call this portion is portion BC, and that should be equal to, looking at this one, this is in terms of our symbol, let me call sigma C, okay, sigma, okay, let me sigma BC, will be equal to the force in this portion. The force in this portion we label is Fc, and divided by the cross-sectional area, and this one, per our statement, this is a circular cross-sectional area. So in this way, the area will be equal to pi over 4 times diameter squared. Diameter is 20, and here for the first time practice, you keep all the units in your calculation. Okay, now for this case, the sigma in portion B, AB, so let me call this is AB. And this one will be equal to the total force, and the total force per our symbol is Fa, divided by the cross-sectional area. The cross-sectional area, and I think we have the dimensions. Here the textbook didn't show it. No, sorry. Let me draw the cross-sectional area here. And for this case, this is 50 millimeter. It's showing is here, and these dimensions I think should be appear in our next page. Let me dig out the information here. Let me move forward to find out that information. Okay, 30. So let me write it up here. So this is 30. Okay, so in this way, this one will be equal to 50 times 30, 15 millimeter square. Okay, so here we have all the expression ready. So the remaining work is to calculate FC and FA. And FC, FA, based upon this free body diagram, if we take the force in, say, vertical direction equal to 0, the force in y direction equal to 0, and then that will be equal to, say, the slope. Based upon this one, you can see this is 600, 800. So basically the slope is 3, 4, and this side is 5. Okay? So from here, we take the force component in the vertical direction equal to 0. So here, 30 kilonewtons downward will be equal to this force component. Okay, so this force component is Fc times 3/5. And then we take the force in horizontal direction equal to 0. In horizontal direction, so that means here we have two components here. This one is Fc times 4/5 plus Fa. So Fc times 4/5 plus Fa equal to 0. So from the two calculations, we should be able to calculate Fa is 40 and Fc equal to 50 and Fa equal to minus 40. Okay, and remember the unit is in kilonewtons. So let me redraw the free body diagram. So here, this is the point B. Around the point B, we are given a loading is 30 kilonewtons applied downward, and just like shown here. And then in this portion, we calculated. And in Fc, this is our assumed directions, Fc, and we calculated has a magnitude 50. And in Fa, we assume in these directions and got the magnitude minus 40. So that means minus 40 in this direction is equivalent to 40 in the opposite directions. So Fa equal to 40 in this direction. So right now, pay attention, I changed the direction and to negate the magnitude, the negative sign here. So now we got everything here. Then we should be able to calculate. So therefore, the stress BC will be equal to calculate using this equation here. So Fc is 50 kilonewtons and divided by pi/4 times 20 millimeter square. Okay, then let us implement this one. carefully. So here 50 kilonewton is 50 times 10 to the 3, and we put the unit here. And this one is pi over 2, and let me convert it into meters. So 20 millimeter is 10 to the minus 3 and meter. Okay. So let me get the meter out here. So that means here the meter here. Okay. So doing this one, do this carefully, and 50 divided by that one, that will be equal to I don't have a calculations, but let me try. This one will be equal to 50 times 10 to the 3, and then divided by pi over 4. And this is the 20 square is 400 square, and times 10 to the minus 6 and Newton meter square. So as long as we can implement this one, so let me leave this one here. Later we can punch calculators. So now this is the unit here. So this is the magnitude of the stress, and this is the unit of the stress. And let me implement the calculation. I should have the calculation here. 100. So this one, let me do the calculation. This is 159 times 10 to the minus 6 Newton meter square. So this magnitude, once we implement this, is 159 times 10 to the 6. Okay. So we, from here, this is the magnitude, and this is your unit. And here, let me make a certain marks here. The first one, we define the Newton per meter square is called the PA. The PA, that is the pascals, the brief of the Pascal. And most of the time in our mechanics material, our unit is the calculations for stress is at the order of 10 to the 6 Newton meter squared, just like this one. Okay, so here we define as 10 to the 6 is the 1 million. So we define as M. M is million. And here is PA. Okay, so basically most of the time for this case we can write up is 159 MPa. Okay, so that is a unit for this one. This is a very common expressions for the unit of the stress. Okay, so now we're back to our calculation here. Right now we have fixed the magnitude of the stress in this portion. And right now I'm going to fix the calculation for the AB. So for AB, the same thing, you will be able to introduce the magnitude of FA, which is 40 kilonewtons divided by these millimeters, and repeat the calculation just like this one. Pay attention to your punching calculators, and pay attention to the unit, and the results should be in our next page here. Okay, but anyhow, yeah. So we take a stop here.